All right, the solubility of organic molecules. Um, there's this rule that you might have heard of. Like dissolves like. This is a fundamental statement people have been using for eons. Like dissolves like. So what does it mean? That means polar molecules, polar, dissolve polar. Nonpolar, dissolve nonpolar. That's what like dissolves like things. Okay? Sodium chloride is a salt. It's incredibly polar because you have a sodium plus ion and a Cl minus ion. So if I were to add this into water, which is also incredibly polar, the salt dissolves in water because I have a polar being dissolved in a polar. Now, if I were to take salt and put it in vegetable oil, okay, it's oil, what's going to happen? Nothing. The salt's just going to float to the bottom, and it does not dissolve in the vegetable oil because this is polar, but vegetable oil is non-polar. Okay. Um, Nail polish. Okay. Nail polish. What do you think nail polish is? Polar or non-polar? If you said non-polar, you are correct. Because when you wash your hands and you have nail polish on, the nail polish stays. The water doesn't, or the soap doesn't dissolve it. What do you need to use in order to get off nail polish? You need to use nail polish remover. Well, do you think that's polar or non-polar? Well, since nail polish remover dissolves nail polish, and nail polish is non-polar, therefore nail polish remover must be non-polar. Okay, so we see these things all the time in our lives, every day in our lives, this rule. So it's kind of a rule that um, you kind of deal with all the time. Okay, most organic compounds are soluble in organic solvents. Well, why is that? Because most organic compounds are relatively nonpolar. Okay, so that's why they are soluble in an organic solvent. Organic really is soluble in organic. Okay, hydrocarbons are a bunch of carbons and hydrogens. Well, is this polar or nonpolar? Well, we just learned on the previous slide that carbon and hydrogen have the same electronegativity, so this is nonpolar. Okay, it also even says it's nonpolar. So hydrocarbons are nonpolar. They are insoluble in water because water is polar. Why is water polar? Because oxygen is much more electronegative than hydrogen, so you have a dipole. Okay, so that's why oil and water don't float. Oil is hydrocarbons. Hydrocarbon is basically an oil. And everyone knows oil and water don't mix. Oil floats on top of water. That's because oil is nonpolar and water is very polar, so they don't mix with each other. Okay, polar organic compounds are water soluble only if they are small and contain a nitrogen or a oxygen atom that can hydrogen bond with water. Okay, remember what hydrogen bonding is. It's an interaction between a hydrogen and a lone pair on another atom. Okay, this is, remember, hydrogen bonding is a type of intermolecular force. If you haven't watched videos on this yet, I suggest you do that before you go any further so that you understand these concepts. Okay, so basically an organic molecule, if your organic molecule is to be polar, it has to have an oxygen or a nitrogen on it. Okay, and you can't have a lot of carbons. There's kind of this rule that says for every 4 carbons you are, okay, let's do it this way. In order for an organic molecule to be polar, for every oxygen there must be no more than 4 carbons on your molecule. Okay, so like if I have, an alcohol that has 4 carbons, 1, 2, 3, 4, this will be polar in water. If I have any more carbons, then most likely be nonpolar. Like if I have something that has like 8 carbons on it, is that 8? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Let's put another one. If I have 8 carbons in alcohol, this would be insoluble in water. It would not be very polar, but this would be polar. Okay, this is kind of a rule of thumb. They don't talk really about it in this book, but that's just, it's kind of true. Okay, just because I have an OH on my molecule doesn't mean it's polar. You also have to have a certain amount of carbons. Okay, and that's for every OH. We're going to see a few examples. So here I have hexane. Okay, there are 6 carbons. It's all carbons and hydrogens. Is this polar or non-polar? Well, it's nonpolar because it's all carbons and hydrogens. So this would be insoluble in water. If I were to pour this into water, I would have two layers. I would have a bottom layer, which is water, and a top layer, which is hexanes. Ethanol, however, has an OH group on it. It has a very polar group. Okay, it has an oxygen. So this is going to be water soluble. Also, it fits that every 4 carbons for every oxygen. I only have 2. Okay. Cholesterol. Okay, without even looking at the molecule, you know that that's basically fat. Okay, but here's the structure of it. What do you notice? It's all carbons and hydrogens with one OH group. Well, do you think this OH group really has a large effect on the polarity? Well, remember I told you, you need 4 carbons for every OH group. I mean, in this molecule alone, I got 2, 3, 4, 5, 6, 7, 8, 9, 9 plus, I don't know, we probably got about like 20 some odd carbons for every OH. So this is going to be very non-polar, incredibly insoluble in water. So you see how you can look at the molecule now and predict if it's going to, if it'll like dissolve in water or if it will dissolve in a non-polar solvent. All right, our first lab, we actually do a solubility lab where we'll actually see this in action. Okay, and just knowing this information will help you tremendously in that lab. You just need to know what the structure is. Okay, if I have 2 compounds, and if one is polar and one's nonpolar, they are not going to dissolve. They're going to be completely insoluble with each other. If one is nonpolar and the other's nonpolar, they will be soluble. If one's polar and the other's polar, they will be soluble. Okay, so I hope this makes sense. This is where kind of all this is all coming to. Let's actually do another example. Let's say we take acetic acid. Sorry about that, guys. This always, I press a button on this pen and this is what happens. Acetic acid. Do you think this is soluble in water, or do you think it is soluble in vegetable oil? Which one do you think? Look at the molecule. Is this a polar molecule or a non-polar molecule? Well, I hope you said polar, because you got this OH, plus you have an oxygen right here. You've got a lot of oxygens on a small molecule. So it's going to be polar, so it's going to be soluble in water, which we know that because that's what vinegar is. Okay, so by looking at, how about like benzene? Let's take benzene. Do you think this is soluble in water? Soluble in water? That's the question. Yes or no? The answer is no. It is not soluble in water because it's just all carbons and hydrogens. In fact, the formula is C6H6. There's nothing polar on this molecule. So it's not soluble in water, but it would be soluble in vegetable oil. Okay? So hopefully this makes sense. But like I said, we're going to be doing a lab on this. So for sure after that lab, you should be good. All right, I'll see you back for the last section.